Okay, in this video we'll see the procedure for solving a series of linear simultaneous equations in MATLAB and Excel. So let's start out. We have these three equations for x, y, and z. And the first step is to write these in matrix form. So if you want to practice that, you might want to pause the video and write these in matrix form. Here's the solution to that. So the first one, for example, is 12 times x plus 32 times y. And since the 10z is on the right side of the equation, you have to bring it over to the left, so it becomes minus 10z equals minus 30, because again 30 has to go to the right side of the equal sign, and so forth. You can see there's a 0 for x in the second equation because it doesn't involve x, but there's our three equations. Now to do this in MATLAB, first of all, the coefficient matrix is entered, and remember we use spaces and or commas to separate elements of a row, and a semicolon advances to a new row, so that's a 3 by 3. Our constant matrix is a column matrix, so again semicolons separating those elements. And finally, to solve, our solution for x is equal to the inverse of a, which is just inv of a, multiplied by the constant matrix C, and there's our answer, 7, minus 2, and 5. Now, earlier we saw that if we have two linear equations, we could visualize the solution as the intersection of two lines. But a linear equation of three variables will form a plane in space. So let's take a look at those three equations we just looked at, and we can generate those three planes in space with a program like SolidWorks. And so each one of those planes represents an equation. Any point that's on that plane is a solution to that one equation. Now where two planes come together, those are going to be the axes that are shown here. And any point that's along those lines satisfies two of the three equations. And finally, where all the three axes, and in fact all the three planes come together, is a single point. And that point is, as you can see, given by the coordinates x equals 7, z equals 5, and y is equal to minus 2. So let's solve those equations in Excel. Let me switch over to Excel. You can see I've got my coefficient matrix and constant matrix already there. So what I can do first is to invert the A matrix. And remember, if I do that, I'm inverting a 3 by 3. So I have to define a 3 by 3 area and type in the equation equals m inverse. Highlight this 3 by 3. And now I have to use, remember, Control Shift Enter to fill that 3 by 3, and that is the inverse of the A matrix. Okay. Now I'll move down here because I want to multiply the inverse of 3 by 3 times the constant matrix of 3 by 1. So my answer is going to be a 3 by 1 with those cells highlighted. I use matrix multiplication, mmult. The first one's going to be the 3 by 3 inverse of the A matrix. We multiply that by the C matrix. Once again, Control Shift Enter, and there's the answer, 7, minus 2, and 5. Now, we don't have to show the inverse like that. If you want to combine the two steps, then what you can do is just start here and say equals mmult. Well, the first thing you want to multiply is the inverse of A. So what we're doing really is kind of stacking those commands. So I'm taking the inverse of this matrix and I'm multiplying it by this matrix. Control Shift Enter, and again there's the answer. And again, if you want to color code those a little bit, they just do help the matrices stand out a little better. So let's see if we can do this. Go ahead and write the MATLAB statements for finding these four unknowns, A, B, C, and D. Okay, here's the solution for that. The A matrix is a 4 by 4. So once again, by the way, if the matrices get too big, you can use some of those techniques we've learned in the Xi book to to write, say, a row at a time and then combine those into a single matrix. But in this case, it's a 4 by 4, so you can see it's written out as shown. The constant matrix, once again a column matrix, and you can also write this as a row matrix and then transpose it. And finally, take the inverse of A multiplied by C, and you get the same answer that we did with Excel. Now, one thing I will show you about this MATLAB solution here is that you don't really have to invert the coefficient matrix. And if you get to a very large matrix, and you know, a lot of the engineering problems you look at, for example, a finite element analysis, they might be running 10,000 or 100,000 simultaneous equations, and so inverting that matrix becomes almost impractical. In a linear algebra course, you learn to use what's called Gaussian elimination. That's a systematic way of solving a system of linear equations. And that's usually what MATLAB recommends. And in fact, the Zybook says you should always use this method even with a small number of matrices. It really doesn't make any difference, again, if you're looking at a 3 by 3 or a 4 by 4. But here's the way to do this with MATLAB. To solve a times x equals c, you use the backslash operator. So instead of having to say inverse of a times c, it's just a backslash c. So our previous example, there's the A matrix, there's the C matrix, and so our commands simplified a little bit, but again, for a large system of equations, definitely the way to go. A backslash C gives us the same answer.